Okay, so in this problem now, the first part we want us to define dot product of two vectors A and B. So again, this is definition, and in the previous first problem we saw the use of the dot product. So you can define the dot product as when you define it, you also have to just give a mathematical expression where you have if you have this dot this, then you're going to have this, and then this, and then cos the angle between it. So of course you look at the words used, but what my emphasis here is that you really have to put up the equation, and of course you have to also state that if you have a vector A, then present it as AXI, AYJ, AZ. Okay. And of course the same thing for B. The text in English so that you satisfy the condition for it. It has to be for high marks. So make it worth it. However, interest here is on part B and how to do it. Then we'll see if we can also do the same thing for C. In B, what are they saying? The bracket is being acted upon by three concurrent tensile forces, F1, F2, and F shown. If the magnitude of the resultant force is to be 40 newtons directed along the positive u-axis, determine the magnitude of F1 and its direction phi. So let's understand what we have here. We have the x-axis. We also have the y-axis. I'm not saying the z-axis, so it looks like we are in two dimensions. So what else are they saying? They're saying the resultant, the magnitude of the resultant, like giving us what the resultant is supposed to be. And they're saying it's supposed to be directed along the u-axis. So the fact that I am in two dimensions, I recall the easiest way to deal with two dimensions is with a table. So I'll go to a table. I'll create a table. So what is the question saying? How many forces do I have here? The question says that three forces in the resultant. Let me accommodate them. So here, this force will go here, second force will follow there, and then we'll have the third somewhere here. So that is what we have. Now, once we're done with that, then of course, the here, so this F1, this will have F2, and this will have F3. The resultant will be just R from the start this time around. The X components will for here, the Y components will for suit. So see, I'm getting one detail at a time. The bracket is being acted on by three concurrent forces as shown. If the magnitude of the resultant is 440, so the resultant giving me how big it's supposed to be 440. So I know something about what comes here, 440. And it is along the positive u-axis. Which one is the u-axis? It's here. And guess what? I know the angle between the u-axis and the x-axis. What does this mean? I can actually start looking at it as the u-axis. Let's view it as my resultant force, as the fourth vector to accommodate the resultant force R. This means that I can already get the x component of the resultant. It will be the resultant itself, cos theta, cos 30 in this case. And the y component of the resultant will be the resultant itself, sin 30. And observe that the y component will be going up, x component will be going to the right. So they will both be positive. I don't have to worry about sign. It's 440. So for the resultant, I have 440 cos 30 and 440 sine 30. So that's for the resultant. What else? Determine the magnitude of F1 and its direction. Fine. So it's like this one don't give me anything about F1. I don't know its abilities. I don't know its direction. All I know is there's an angle it makes. Phi is an angle F1 makes with a positive y-axis. So let me deal with it as well. If this is where its y component, its x component is, for the horizontal one, and this is where its y component is, then observe that I can get the expressions for the x and the y. The x is opposite to that phi. So I'll have the x component to be equal. Since opposite related by sine. So to be the vector of f1, then sine the angle phi. It's going to the right, so I expect it to be positive. The y component is going up, it will also be positive. F1, it's side by side with the angle phi, so it is cosine. So this is the description for F1. Next, F2 and F3. Well, for F2 and F3, they've given me things. F2, for example, it's all along the x-axis, and it's going to the positive x-axis. It has no y component. So I can get that 200 at its stake. It has 200, so very clear. So that 200 is in the positive x section. Again, let me put the units in advance there. Meaning the y component is 0. That sorts out F2, and quickly we go to F3. Again, F3, we see that they're using that triangle. Seems like they like this approach. So they're giving us a small triangle. And we have to relate it to what is happening elsewhere. So again, we can choose an angle completely up to us. I choose my theta to be here, meaning that I'll relate it to this one here. So this is 3, this is 12, this is 13. So for my small triangle, I have have 3, 4, and 13. The angle I'm using is this one here. From here, we see that sine theta will be 3 over hypotenuse. For cos theta will be 12 over 13. So once I'm done with the small triangle, I can now do with the big one. The adjacent is here, which is the y component. It has to go down, so it will be negative. So the y component will be negative. The vector itself is F3, which is 260. And then cos is side by side with that theta. So cos theta. But we saw that cos theta is 12 over 13. So it's going to be minus 260, 12 over 13. 12 over 13. This is the same as what? When you multiply, $240. So y component comes out as negative 240. In the same way, we can get y for x component. X component will be going to the right, so expect it to be positive. And it will be, that's 260. But it will be opposite to to the angle theta, so it will be sine. But we recall that sine is 3/13. So we now have this. Is this 60? So get 60. So from here, we now want to find what F1 is. So remember, when you add this plus this plus this, they should give you the resultant. What does that mean? When you add F1 sine phi plus 200 plus 60, you should get 440 cos 30. So from here, we can say that F1 sine phi has to be equal to 440 cos 30 minus these two add up to give us 260. So we can actually even hold on to this one as well. In the same way, when we add this plus this plus this, they should give us this. So F1 cos phi plus 0 plus negative 240. This should give us 440 sine 30. Sine 30 is half. Half of 440 is 220. This crosses to become positive 240. These ones can add up so that we get 460. That's 2. Now notice that you have equation 1 and 2 with two unknowns, F1 and phi. You can easily make F subject of the formula and eliminate, or you can divide equation 1 divided by equation 2. From the left-hand side, you will have F1 sine phi from equation 1 and F1, this is F1, F1 cos phi from equation 2. On the right-hand side, you will have this from equation 1 and from equation 2, you have 460. Here it's completely up to you how you simplify it. F1 cancels, have sine over cos, which is tan, is equals to this. I'm just avoiding dealing with decimals there, so I'm keeping the whole thing. And then finally, phi will be tan inverse of this. So what would be phi? What's that? 14.743, right? So to the angle. Having found the angle, you can pick any one of these equations about 2. From 2, we can now find what F1 is. F1 will be equals to 460 divided by cos of that angle. So 14.7. What are you getting? 475. So that becomes our F1. Any question? Consider this was straightforward. 10 marks, once you understand how it was going, those 10 marks were free.
Like how negative, like how like this one is negative, this one is positive, is okay, that one is
Okay. So okay. So once you are analyzing them, what I look at is, let's say I have a vector like this. So this is a force vector F. It will have two components. And the x component, I start from the tail. The x component will go this way. The y component will go that way. So I look at this. The x component is going to the left. So I know the x component will have negative. The y component is going up. So I know the y component is positive. Regardless of the angle I will use, whether I'll use the angle which is here, I'll use the angle which is here, all I see is the x component is going to the left. It must be negative. Do you get that?
yes.
When the angle I use is measured anti-clockwise from the positive x, then I don't worry about the direction because this angle will position the direction for me. For example, I use 120. I know if that is 120, then this angle here must be 60. So if I was to get the angle, the direction, the x component using 60, my value for the x, for example, I'll say since I'm using 60, going to the left, so I'll probably negative. Then I'll have the force itself, whatever the number is, then I'll say cos 60. Cos 60 is half, so I'll have negative 0.5, whatever the value of f is. But if I want to use the 120 now, I don't have to worry about the direction. I'll say the x component will be equal to the force itself and then cos 120. Cos 120, when you evaluate it, you will see that it will give you negative 0.5. Which again reduces the same expression. So I see whether it will be negative or positive by analyzing where the arrow is pointing. If my force vector has been given as, let's say, a vector like this one, and then the angle given, let's say the angle given is this one. Again, all I need to do is create a right angle triangle with the angle inside. First, I need to go down, then I need to go to the left. X component is horizontal, Y component is vertical. So already I see the Y component is going down, I expect it to be negative. The X component is going to the left, I expect it to be negative. You seen that? So that is how I tell my directions. For this problem, we are done with what we are covering tonight. The thing that follows in terms of B here, this one will have to involve the moment, which is going to be our 41. So we'll leave this one out. Right? Let's check out the other problem and let's see if it has something that we need to touch on as well. And that's this one. Okay, so yes, we do have some like things here. Okay, so for this one, our interest here is only going to be question 4. We're seeing question 3B there has to do with the couple moment, first couple system. So the couple system there, that's couple moment. So we are at the moments there. So we'll know that tomorrow night. But for tonight, we have question 4A. Do we have to touch on B? Draw a complete free body diagram for the bar AB. Free body diagram is also not in a coverage for tonight. So let's look at question 4A. So in 4A, what is happening? We'll try to be a little bit quick about it.